All right, so here is going to be our lesson for solving simple equations. So now notice we're talking solving, not simplifying. So the difference between the two, solving, we're actually going to get an answer. So meaning our problem starts with an equal sign and it ends with an equal sign. It's going to be x equals blank or z equals blank or y equals whatever letter they're using. Our entire goal with this and our next section of like complex equations or multi-step equations, you want to get whatever letter is in that problem simplified all the way down so it is fully by itself. And that is what we call solving. So just to kind of like tee it off here, there's going to be a lot happening. You do not have to write all of this down, so I'm just going to kind of explain some of it to you. So an equation is a statement where two expressions are equal. So if I say 4x plus 3 equals 9, that means that 4x plus 3 and 9, if I had one of those judges' scales, those gold things where you put stuff like weights on the side, 4x plus 3 and 9 would make it so that those scales are equal with each other. Because that's what the equal sign means, is that 4x plus 3 is somehow the same value as 9. A linear equation in one variable is an equation that can be written in the form of ax plus b equals 0, where a and b are constants and a is not 0. So that's just saying that we're able to write it with one letter. A solution of an equation is a variable that makes the equation true. So when I go through and solve for x in that top equation that I just wrote, whatever number I get is what makes it true. So inverse operations are things that undo each other. So our two inverse operation sets are addition and subtraction, and then multiplication and division. So obviously, addition and subtraction are opposites. They will undo each other. If I add 5 and then subtract 5, nothing changes. Same thing with multiplication and division. Equivalent equations are equations that have the exact same solution. Okay. Then the stuff that I have down here is basically just kind of like the fancy way of saying why addition and subtraction are opposites of each other. So nothing super crazy to add here. We're never really going to actually reference the properties, but just in case you wanted to see them. All right, so for here, solve the equation, justify each step, and then check your solution. The justification piece isn't necessarily going to be as big here, but looking at my letters, okay, or looking at number 1, when I start talking about solving these, my favorite thing to do is make circles. Okay, so if you're unsure of what has to happen, and when we have one-step equations like this, it's pretty easy to see what we have to do. However, once it gets a little bit harder, I kind of want you to be familiar with this tool. So I always just circle the letter that I am trying to isolate, the thing that I need to get by itself. I need to get x alone. And then I'm going to circle whatever is next connected to it. In this case, it's that -3. And I stop once I hit the equal sign and there's nothing else on the side with the letter that I have to solve. Well, if you think about like those Russian nesting dolls, where you have the really big one and you open it up and then it's the next size and you open it up and it's just a little bit smaller, but it's the next size and you keep going, that's our goal here. So that little circle, I can't get to that until I peel off that top circle. So if I have a -3, the opposite is going to be +3, and I have to do that to both sides of my equal sign, just kind of like both sides of the fence, which then cancels that out and it peels it back. So I have my x equals, nothing left with x, -5 plus 3 is -2. Then I could reevaluate and say, is there anything else left that I have to circle? Nope, because x is already by itself. That completes our goal. Now, checking our solution, very simple. We're not necessarily going to do this with all of them, but just as like a refresher, if you wanted to check your work, we would plug -2 in for where I have x in my original equation. I always put whatever I'm plugging in parentheses so I can visibly see what I substituted in, just in case there was any error. And then I would say, okay, well, is -2 minus 3 -5? That is, in fact, -5. -5 equals -5, which is a true statement, right? If it said -18 equals -5, That's not true, but negative 5 equals negative 5. So that would be checking. Okay. All right, number 2, heading over here again, that circle idea here and then here, stopping once you hit that equal sign. That kind of just shows you what we have to attack first. So that positive 2.8, opposite or inverse operation is negative 2.8. That cancels out my equal sign, my y. Now 0.9 minus 2.8. Minus 2.8, grabbing my calculator, is negative 1.9. Okay, now, it does not matter if your number is on the right or the left. Like if you notice they are kind of written opposite of each other. I don't care which way you have it. It's fine either way. Checking your work. Okay, we'll just check it for this one more time. So I have 0.9 equals. Now, negative 1.9 is what I substituted in, plus 2.8. You could use your calculator. Negative 1.9 plus 2.8 is, in fact, 0.9. Okay. All right, so no more checking my work. I probably won't necessarily make the circles anymore either, because once we get going through these, I might just show you what they look like with multiplication and division. But addition and subtraction, obviously, like there's not much to it. So let's move on to the next piece. Actually, I'm going to have you try these 3 on your own. I know that middle one has a fraction, but they already have the same denominator, so it should not be much. Remember, we can always bring that negative symbol up to be considered part of that top number. Okay, so go ahead, pause that video. I'll give you about a second head start, and then I will start going through the answers on here. All right, first one here, I have a positive 3 next to that n. My opposite is going to be a negative 3. So negative 7 minus 3 would be negative 10. All right, here I have a negative 1/3 next to my g, so I'm going to add 1/3. Again, cancels that out. That's the whole point of why we do what we do. So I have a negative 2/3. Let me just write this out over here so you can see it, plus 1/3. Well, when we're adding, the denominator doesn't change. Negative 2 plus 1 is negative 1. So I have a negative 1/3 g, or for g. All right, so then my last one here, identifying my letter, seeing the thing that's next to it, I'm going to do the opposite of it, meaning negative 6.5 minus 3.9 to get negative 10.4. All right, so addition and subtraction, very chill. Multiplication and division. So again, here's that same kind of text box talking about the different properties. Again, we never really talk about the properties using their names. However, it's probably good to know just in case. But addition or multiplication and division undo each other. Okay, so taking a peek at this guy. So in this case, okay, I've got a couple things happening. I can see a fraction bar. Going back to my fractions video, fractions and division are the exact same thing. So if it helps you to write it out differently, you can. Otherwise, the biggest thing to remember is that there's a 1 on that end. So I can bring that negative up to the 1, or I can bring it down to the 5. Anytime that I just have my singular letter on the top of a fraction, I would actually probably bring that negative to be down in the bottom with the 5. Okay, so when I'm doing my circles for division, okay, I would circle my letter. If there were anything attached to my letter that wasn't a 1, so say there was like a 19 in front of that n, that would get my next circle, but there's nothing there. Then it's going to be whatever I'm dividing by, and then it would be whatever if there was anything added or subtracted next to it. But in this case, I can see that I'm dividing by negative 5. Notice how my circle is kind of weird shaped, and that's okay. So the opposite of dividing by negative 5 is going to be multiplying by negative 5, because that'll cancel those out. So I just have my n. negative 3 times negative 5 is a positive 15. Okay, now again, if you wanted to check your work for that, you could. So I have negative 15 being substituted in, or positive 15, my bad. Everything else has been negative 15 divided by that negative 5 equaling negative 3. Well, I can focus on it in a couple different pieces. Again, doesn't matter where you have that negative for that fraction. So if I leave it and I just do 15 divided by 5, notice how that simplifies down to negative 3, and negative 3 does equal negative 3. All right, now this one. This one's always fun. Okay, notice how they're both being multiplied by pi on both sides. This is kind of an intense example to start with, so I'm going to show you one very similar to it over here. So if I said 5x equals negative 2 times 5. If they're both being multiplied by 5, doesn't that mean that my problem is just 5 times as big as what it originally could be? So if they're both being multiplied by 5, well, my next obvious option, okay, thinking circles wise, okay, circle my x, circle that 5, I'm going to have to divide both sides by 5. So they just cancel out. So really all I have is x equals negative 2. So kind of applying that same logic to this problem, because they're both being multiplied by pi, if I divide both sides by pi, it just cancels out and I'm just left with negative 2. Okay. All right. Next one. Again, another multiplication here. So here is kind of what my circles look like with like less intense of an example. 1.3 times z, so my z gets the smallest circle, 1.3 because it's directly connected to it, gets my next circle. Multiplication tells me I'm going to divide by 1.3 on both sides, so z is alone. 5.2 divided by 1.3 is 4. All right. I don't think there's anything else on that page. So let's try a couple more. I'm going to give you about 30 seconds to do these. So go ahead and pause this video, try these problems. All right, so taking a peek at my first one over here, again, thinking circles wise, if you're not sure what to do, notice y gets the smallest circle, that divided by 3 gets the next one, so I have to multiply by 3 to get it to cancel, so I'll have negative 18. This one, again, has that same kind of logic. We're going to divide both sides by the thing that they have in common to get it to cancel, because then all I have is 9 equals x. And then number 3, circle your letter, circle the next thing. It's multiplication this time. So I know I'm going to have to divide by 0.05. That cancels. And 1.4 is 28. Which I know kind of looks wrong, but a decimal divided by a decimal actually gets bigger because of the division of fractions that's technically happening. It's crazy. We can talk about it in another video as well. But here are those. Now let's try writing an equation and then solving it. So in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Hint, use D equals RT. Well, they're not telling us what D, R, and T are. How is that even helpful to us? Well, D is probably going to be my distance, because that makes sense. R, I'm not sure what R is. T is probably time. Now, do I know my distance and my time? I know my distance right there, and I know my time right here. So R is probably the thing we're going to solve for, you guys, because that I have 2 of the other pieces, and they want us to write and solve. So my distance is 200. Now my time, because I don't have my rate, my time is 19.32, and I can just put R on the backside. It looks a little bit goofy if you keep it in the front, but not a bad deal if you do. Okay, so looking at this, it is a one-step equation still. If you need to make those circles, you make those circles. I see that multiplication is happening. So the opposite of multiplication is division. So I'll have 19.32 being divided on both sides. So 200 divided by 19.32 is, big number. So rounding to the nearest hundredth. Hundredth means 2 decimal spots. So I have 10.3519, blah, 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 blah. I have to look at the 1, and that tells me what to do to that 5. Now, if the 1 is less than 5, so if it's 0, 1, 2, 3, or 4, then that 5 is going to stay where it is. If it was a 5, 6, 7, 8, or 9, then I would round that 5 to a 6. But because that 1 is a 1, I'm going to have 10.35. So his average rate was 10.35 meters per second. All right, here is our next one. So you thought the balance in your checking account, so that's just going to be kind of like your normal account where money gets put when you get paid, was $68. You thought when your bank statement arrives, you realize that you forgot to record a check. The bank statement lists your balance as $26. Well, write and solve an equation to find the amount of the check that you forgot to write. Well, you thought you had $68. Your actual balance is 26. So that means I subtracted something that I forgot to put from that $68 total. So if I have $68 to start and I'm missing this X value, it is going to equal $26 once I figure out what X is. Okay. Now this one gets people because that X is negative. We look at the 68 and we say, ooh, something's got to happen with that 68, but is it plus or is it minus? My 68 itself is positive because there's nothing out in front of it, meaning that if I were to rewrite this, like we've kind of talked about before, I could technically say this, right? Negative X, because my signs just have to be the same, plus 68 equals 26. So you could rewrite it this way, and that would be like probably a little bit easier to see, honestly. But if you can't see that and you don't remember, and I can show you guys what that one looks like over here, because it's honestly a little bit easier. If I couldn't notice that though, and I'm doing this one, and I'm like, ooh, I don't know what to do, I would move the thing that is freaking you out. I would add X to both sides because it makes it positive, and then I don't have to worry about it. So I would have a 68 equals 26 plus X, right? Because I can't combine them, but we've seen from our combining like terms section, I can write them like this, right? It is perfectly okay to say 26 plus X because we don't know what X is. Now I can look and say, all right, I need to subtract my 26 here to figure out what that final total is. And I believe it is 42. Okay, now looking at that other way, all I would have to do here, subtract my 68. I would have negative X equals negative 42. And then I could divide both sides by -1, or I could multiply by -1. It doesn't really matter. I would just have to do something, aka flip the signs on both sides. Because we don't want a negative X, we want to know what X is. Okay, that is solving simple equations.